All right, this is lesson 4.1. It's going to cover increasing and decreasing graphs as well as critical numbers, but we're going to break this up into a two-part lesson. So you have here a function is said to be increasing when its graph rises as it goes from left to right. So this is really important for us to note. We're going from left to right. I want you to pause the video, draw this graph, and then we're going to start to highlight with our highlighters. As we go from left to right, so I'm going to start on the far left here. As I start to highlight, you'll see my highlighter is going up. So I'm increasing. And then all of a sudden, I'm going down, so you can see where I'm decreasing. Grab that highlighter again, and now I'm increasing again. So increasing as I'm going up from left to right, decreasing as I'm going down, and increasing again. That's what you're seeing on this graph. Now we can tie this into slopes and derivatives. So I'm going to show you the same graph, but with tangent lines drawn here. So you can see as we have our graph and our tangent lines, you can see where it's increasing would have a positive slope, and where it's decreasing would have a negative slope. Okay, so in this graph, you're seeing the slope of the tangent lines. So this chapter will tie in everything you've done with derivatives into your graphs here to determine when graphs are increasing or decreasing. We're going to study graphs like this. We're going to look for intervals, and we're going to look at specific examples where you'll have to solve inequalities. So let's take a look at our first example here. We're going to consider the function defined by f of x equals x squared minus 8x plus 7. We're going to take this function, and if we want to determine where the function is increasing and where it's decreasing, we'll think about it. In the grand scheme of things, if we just sort of study the slope where it's increasing or decreasing, meaning where it's greater than 0 or where it's less than 0, right? Negative and positive slopes. So positive is greater than 0. Negative would be less than 0. In an example like this, if we're solving this algebraically, meaning without a graph, the first thing we would have to do is take the derivative. Because when we take the derivative, we have the slope of the tangent line. So again, we know what this is. This is a parabola. When we actually sit and we graph that, it's an upwards parabola. So we know there's going to be parts where it's decreasing, meaning where it's going down, right? And we know there's going to be parts where it's increasing as well, right? Where the graph is going to be going up. We're trying to find out, without graphing, how to do that. So again, take the derivative because that's going to be the slope of the tangent line. And so we've done this in our last chapter. The derivative of f of x would be 2x minus 8. So again, this is the slope of the tangent line. So if I find out where the slope is positive, I'll find out where it's increasing. And if I find out where it's negative, I'll find out where it's decreasing. So step 1, take the derivative. And step 2, if I want to find out where it's increasing, again, emphasize this, I want to find out where the slope is positive, where it's increasing, right? Think about that. Over here would be positive. I'm going to take 2x minus 8 and set it greater than 0 because numbers that are positive are greater than 0. So we're going to go ahead and solve this inequality, and we'll get 2x is greater than 8, and then divide by 2 on both sides, and x is greater than 4. This means on the interval where x is greater than 4, the graph will be increasing. So far, this parabola, where x is greater than 4, this parabola is probably heading, I don't know where the vertex is because I haven't calculated it, but let's just pretend like it's over here. Where x is greater than 4, the graph is going to be increasing. That's what this means. And so you can already probably guess it's going to be decreasing where x is less than 4, but let's verify that. So if we want to find out where it's decreasing, we want to find out where the slope is negative, right? Which means numbers that are less than 0. So we'll take that inequality, that derivative, that slope, set it less than 0 to find out where it's decreasing. And solve here, and we'll find out, x is less than 4. So that means x is less than 4. That's probably where it's decreasing. Now I'm just going to let you know again, I don't have the correct vertex here, but I know that the graph is going to be decreasing less than 4. And when I go beyond 4, meaning if I go to 5, 6, 7, 8, it's going to be increasing. And that's what this question is asking us. Where is it increasing or decreasing? So we say it's decreasing on this interval where x is less than 4, and it's increasing on this interval where x is greater than 4. And that answers the question. We'll get into some word problems later. I'm going to jump into some homework questions. I know you have the odds for homework, so I'm going to do some evens with you. This first example is telling us to study each graph to determine the intervals on which the function f is increasing and the intervals on which it's decreasing. We're going to use inequality or interval notation, and we're looking for intervals, meaning all the values of x. All right, so grab your highlighters. Let's sketch. Looks like I'm increasing here, going up. Let me make that highlighter a little bit smaller. Here we go. Going up, and then I'm going down, and now I'm going up again. So I want to find out those intervals from green. It looks like -2, that's -4, that's -6 on your number line. So from where x is -6 all the way to -4, look at that. Where x is greater than 6, but less than 4, that's where it's increasing. And then again, green section, it's increasing. Let's pretend that this is continuing to go up. It's increasing for where x is greater than 2. And then the red section looks like it's between, let's emphasize this, that this is increasing. That's our intervals. And then decreasing, the section in red, it's decreasing between -4 and 2, okay? So you can almost like even highlight the x-axis here and section it off if you really need to see those numbers. So again, from -6 to -4, that's where it's increasing, and then x is greater than 2, it's increasing again, and then between -4 and +2, that's where it's decreasing. So these are considered to be intervals using inequalities, okay? Interval notation works a little bit differently. If you wanted to use interval notation for this, what that would look like is 6, 4. For this one, that would look like 2, infinity, because we're going to positive infinity. Okay, let's look at number 4. You can see on this graph there are sections where it's increasing. There's sections where it's decreasing. And then it looks like it's flatlining here. So it's neither decreasing nor increasing. It's just constant, right? It's 0. So again, increasing from looks like -6 to about -3. So my interval is going to be like this. And then decreasing from, let's see, 2, 4, from 5, and then it looks like it stops at 6 there. So from 5 to 6, I'm going to put D for decreasing, okay? So reading the graphs are pretty easy. And again, intervals are all based off of your values for x, okay? And then when you get to these questions, again, if you're trying to find out where the function is increasing or decreasing, we're going to tie that into slope, which of the tangent line, which means we're going to find the derivative f prime of x. And then if we want to find out where it's increasing, we have to set f prime of x greater than 0, right? If we want to find out where it's increasing. If we want to find out where it's decreasing, we would take our derivative and set it less than 0. That would help us find out where it's decreasing. So let's do a couple more. This is similar to the examples I just did 2 examples ago. Let's do number 8. Number 8, derivative 2x minus 14. So if I want to find out where it's increasing, I'm going to set 2x minus 14 greater than 0 because I want to find out where it's positive, right? Numbers that are greater than 0 are positive. We go ahead and solve. And so this is the interval where it's increasing. Decreasing, we're going to take 2x minus 14, set it less than 0 because numbers that are less than 0 are negative, and we want to find out, that negative slope where it's decreasing. Okay, so x is less than 7 is where it's decreasing. So let's just get a sketch there. Again, we know it's a parabola because it's a second degree equation. And we're saying 1, 2, 3, 4, 5, 6, 7. It is, let's see, excuse me, increasing here, decreasing on this side. And that's it. If you have any questions, let me know.